Hello and welcome, dear viewer, to the third video already about Powder, my new programming language. Last time we wrote a bunch of Lexing code. We started the Lexer, and I didn't actually do anything since the last episode. I just cleaned up the commits and stuff. So what I'm going to do now is just continue the Lexer, and the goal for today is to get this entire thing lexed correctly, including the numbers, which should be the hardest part. Let's restrict ourselves to like decimal numbers for now. We can put in hexadecimal later on. Yeah, so let's start with that. First of all, let me actually check that from keyword can parse N64. That's great, because otherwise we'll have to deal with that later. And I think then, if we're already here, we can start with these symbols. So if you remember last time, okay, so let's do that again with a // of course. Yeah, okay. So if you remember, like we were able to parse the comment, we were able to parse the function and main, and then we crashed on this open bracket, which we do down here, like on any other character we crash for now. So I won't do any more advanced error handling today. That will be for later. Like we'll have like a result up here, but for now I'm not going to bother. So yeah, let's just continue, I guess. I guess we can actually like use the default case to handle all the symbols, because we will have like an explicit case, for example, for string literals, which we won't have today, but later on. We'll have an explicit case for all numbers, which is just 0 through 9, basically just like this. And yeah, so we can basically just handle all other cases here. We can just say so this is the case for symbols. Let's maybe say that. Single character symbols. So let's, as I was saying before, let's start by writing the function that can actually create these symbols from a string. So public function from symbol char this time. That's another option, self match symbol. And now, okay, basically just have to do this a whole bunch of times with the open, close paren, open curly, close curly, colon equals semicolon. These all get pipes. Maybe I want to speed that up by doing that. Okay, and then we can say more multi-line editing. Some self : and then we have to use open brace. Also, I'm kind of dumb actually. No, I'm not actually. It doesn't work. I was thinking that we can just wrap the sum around the entire match, and have to like not repeat ourselves here, but that doesn't work because we have the default none case. Anyways, that's not big of a deal. So close brace. That's parenthesis. So if you didn't know, parentheses are these guys. Braces are these guys and brackets are these guys. That's the difference. So let's stick to that terminology here. And of course, we'll need some commas here. This is open brace. Oops, close. Missing my keyboard. Colon equals and semicolon. This could be a const function. Thanks, Calliope. That's a nice suggestion. Why can't this be a const function? Probably because string. Let's try that actually. Const. Yeah, because of string. Yeah, because like this is dynamic allocation. You can't have dynamic allocation in const functions. Makes sense. I mean, we don't need it to be const, but still a nice suggestion. These are all not constructed, but they will be in just a moment. So let's go here. Do the same thing as up here. Let symbol equals let symbol character is state current char. We store the start up here, right? So we can just state advance. So we advance by one character. So we then can again use end as the current position as the end, which is super convenient. So let's see here, state advance. If let some symbol type the token type from symbol, the symbol char, then we can say print line found symbol of type, the exact same thing as up here, symbol char symbol type, and then tokens push token which starts at the start and at the state's current position, uses this code, and the type is the symbol type. Cool. And else we're going to actually let's do the result thing up here. Result factor, and let's use string as an arrow type. For now we'll have a proper arrow type with like line information later on, but right now I don't want to worry about that too much. So this is this is okay. Oops, I've been working with optional too much. And then here we want to have return error, invalid, unexpected, token quote. We need a format for that. And the format takes the symbol char. That should be it. I don't see anything obvious that I missed, so let's run that. Ooh, that got us all the way back here. If you didn't catch it, here's the full thing. We have symbol, open parenthesis, close, open brace. Then we get const. Again, like that's what we implemented last time. Identifier, colon, N64, which is a keyword, and the equals symbol. Fantastic. And now, of course, we actually print the error properly instead of just crashing, just much nicer for error reporting later on. And the error is also correct. Unexpected token 7. Great. So let's continue by implementing the 0 through 9, implementing integer literals. Now, you have to remember that if this is not maybe we have something like this, for example, or 890 something, I don't know. Anyways, so basically if we hit a single number character here, or like multiple number characters, it might not automatically be an integer literal. There are some cases where it can only be an integer literal, namely when we have like the 0x or 0b, b or 0o for octal prefix. Those are prefixes for other bases, just for integers. But if we have an actual integer, if we have a float, we still have like an integer, then a dot, and then basically another integer, although this integer can start with arbitrary amount of zeros. But I think actually we'll allow something like this. So what I just did was type out the exact same number. So this is still 78. In many programming languages, this will be invalid because a leading 0 signals an octal number, and 8 is not a valid number character for octal because octal only goes up to 7. That's why it's called octal, because it has 8 symbols, 0 through 7. But I think like that's a historic unnecessary format, and octal also is a number format that we don't commonly use nowadays. It's mostly used for things like file permissions, where like every file permission is a the file permission has 3 parts, and every part can be every part has 3 bits for read, write, and execute. So you use octal for that, something like 777 signals. Everyone can read, write, execute. The group can read, write, execute, and the owner can read, write, execute. If you want to look up that, maybe I'll put in a something in the description for you. So that's one of the main applications of octal nowadays that I know of. Let's end the tangent here. So all to say that I don't want to support this legacy format, so we can just allow an arbitrary amount of leading zeros, and we'll just deal with that in the parser, which shouldn't be too hard anyways. So we can allow something like this, which means we can reuse all the parser code for the part before the decimal point and the part after the decimal point. So, but let's start with the simple integer, something like 78 or 0. Now you might already be wondering about plus and minus are just symbols as far as the Lexer is concerned. So we might add those. Let's actually plus. Let's actually do that right now. So we just have to add 2 more lines. So we just have to do plus, minus, and that should be that. And also that's how you can see, like, once we have this basic structure in place, it's really easy to add things like new symbols. So yeah, let's actually parse that. I don't know. Let's put a plus in here, just so that we, for example, verify that we can have no spaces in here and it still works, because the only thing that's concerned with spaces right now is the next word function, because that looks at while there's an alphanumeric character, and you can have something like a colon directly after it. So white space is optional, except like inside of a word. Of course, that wouldn't make any sense. Anyways, let's try a simple next number function. next integer, next number sequence. Let's make it very general. Let's call it next number sequence, because like integers can also have this later on. They can also have this base prefix, which is not part of the number sequence itself. So in that case, we will parse the base prefix first and then append the number sequence afterwards onto it. And so this is like the most general thing that I can think of right now that will allow us to use it in a lot of different cases. So we get a stir reference with our lifetime as usual. And also I was a bit distracted a moment ago because I was thinking about the fact that we can extract common logic here. So this looks really weird. We can extract common logic here because this check, like this function will be exactly the same, except it has a different check here. The check here will be is numeric. So I believe what we can do is have a next of type, of kind maybe, and then have a predicate, which is a function we call on self.current, we call with self.current char. So it's a function that takes in a character and returns a bool. Read, let's comment that, read the next false, it's the longest continuous sequence of vectors starting from the current position. That's a position which from which the predicate returns true. Okay, so this is cool. Yeah, we can make this public. So for example, if the Lexer down here needs a very specific next of kind, like a one-off next of kind thing, it can just use this procedure as well. So that's still a string. So we can grab this. And we'll have the same behavior, like it just stops. As that while predicate self.current char. That's all we should need. And that should be next of kind with a closure that doesn't call into self.current char, but simply uses the character that is passed in. I'm going to rename this character, no unnecessary abbreviations. And this is self.next of kind. So character is alphanumeric, and we can remove the brackets actually. Character is alphanumeric or character is underscore. Next number sequence is self next of kind with character is numeric, I think, probably. One of the general categories for numbers. Oh shit, yeah, that's that's a lot of category. Okay, I think we need is ASCII numeric or whatever that's called. Yeah, okay, ASCII numeric. No. Is alphanumeric. Not getting any. It is ASCII whitespace. complaining about? Yeah, okay. What is the error here? Redundant closure. Char isn't. Ooh, fancy, right? Right. I can just pass that function in and of itself. That's cool. Now, don't we have is ASCII numeric? I don't know, let's see, that is ASCII digit. Yeah, that's what it's called, 0 through 9. Cool, okay. I think I can make this a very concise one-liner. Is that all? Expected function pointer. And that takes an end. Oops, do we have like an... Oh, that's sad. Yeah, I wanted to do this nice thing. Okay, it's not letting me do the nice thing. Then I'll do the slightly less nice, but still kind of nice thing. ASCII digit. Okay, chill. Yeah, because this will automatically, I think, convert. Yeah, it will automatically take a reference on character because it can. The self-current char, it's returning the char itself. If we make this function take end char and that here, I think this should work. Amazing. Okay, that's like this is just beautiful. I love this kind of code. It's just it's both obvious, elegant, compact, and easy to maintain. Like it's all the good things you want in software. Okay, next of kind, next word. Yeah, now we need the starting condition, so to speak, which is just 0 through 9, which will give us let number equals date next. Oops, we actually want next number sequence. Of course, I'll actually put a fix me in here. Fix me. Oh, down here. Parse base prefixes 0x, 0o, 0b. It's probably the ones I want to support. That's the standard 3 you need: hexadecimal, octal, and binary. So for now, we'll just assume that the entire thing is like one number. I mean, we could have like a special case for 0 in that case, I think. But yeah, for now, let's just ignore it. Okay. Then we'll just, there's nothing that can fail here. And because we know we have at least one number, because we check up here. Print line font number and number. Tokens to push a new token which start and state current position code, and the type is for now it's just the integer literal, which we need to prefix with token type. Okay, let's pull out the console and try that. Which now we broke, like with this AND thing here, we broke the other code. I didn't even notice. I think we can just, yeah. Sometimes this is a bit silly. Now we get an invalid Lexer position 81, but first of all, let's see. We have number 87. We don't have a plus because I didn't save this. Let's try that again. We have a plus, a 78, a semicolon, var y colon n64 equals 0, semicolon, close curly. Okay, now we get an invalid Lexer position because we check current char while we're already past the end. Okay, let's see if we can fix that. While not state is end. So yeah, we crash up here. Let's actually put in Rust backtrace equals 1, because I don't actually know where we exactly crash. What is it complaining about here? Oh, put a semicolon. Yeah, because yeah, I don't know. Maybe we're trying to skip white space or something. Yeah, let's just. Oops, I think it's easier if I copy that. By the way, if you're wondering about that syntax, that's just how you have to define environment variables on PowerShell. It's really ridiculous. Microsoft, please fix it. But yeah, that's just what you have to do. Okay, here we go. That's a Lexer up here, and we get an unwrap somewhere, and that's a current char check in skip white space. Okay. Yeah, so we first check if the current character is white space, and then we check if we're not at the end. I think it's enough. If we actually, that also goes for the next of kind down here, where we first have to check, okay, are we not at the end? And if we're not at the end, yeah, then it's safe to call self current char, because that thing just crashes whenever we reach the end. Is there any other case of that? Well, we have advanced, but advanced doesn't do any indexing, so that's fine. And up here, yeah, we check state is end, and then we call all the other functions, and all the like internal functions should, if we call advance, something like advance manually, it will, we must check whether it's actually at the end. And if we're using built-ins, so to speak, something like next word, next number sequence, skip white space, then we can just rely on the fact that it will basically stop whenever we reach the end. So I just noticed, actually, you might have as well while I was scrolling over, we have a state.advanced here. But I think that's fine, because we advance, then we like parse the damn thing, and then we return to the while loop start. And if we advance past the end, we will hit this condition as false, and we will bail out of the loop. So I think that is fine. I was very careful in the last episode, like programming all of this is end code, because I know, like from writing a bunch of lexing and parsing code, that it will always fuck you up, because you have to be very careful when you're checking the indices and when you're advancing the indices. So I think this should be fine now, except it's not because I didn't save. Let's see. We're still not fine. We're still hitting current char at Lex. Oh, right. So we have the last piece of white space, which is just a new line. I think we have to... like, after skipping white space, check again. Oh, we do have to do that. Bloop. Cool. I think that's it. Let's actually pretty print that. Can maybe see it a bit better. Yeah. Sick. So they all have their reference to the code, of course. You have to remember that this code up here somewhere, it's just in one location, so we're not storing a copy everywhere, which would be an issue for big files. But yeah, that looks like a stream of tokens to me. Comment, function identifier, open parenthesis, close parenthesis. Yeah, and we have index 33. Let's check that manually maybe. Maybe not for this late one, but for the first important one, 24. 0, 1, 2, 3, 4, 5, 6, 7. 23, 24. Looks correct to me. Either way, I just realized while counting that manually that we can do this automatically. Because we already have, from the last episode, a function that gives us the text of the token. So basically, let's write a simple display impl for token. Impl display for token. And we can then, that's probably std format or something, I don't know. Std format display. It is. And we need the public function format with self. Result of letter error, I don't know. I don't remember. Been a long time since I did that. That's std format display and formatting. Doesn't exist, probably. Std formatter type prime underscore something, I don't know. Do we actually need this? No, we don't, because it's an anonymous lifetime. What does that thing even return? Let's see. It's a result. Oh, it's a format result. Right, makes sense. Okay. So we need result as well. And this is probably ambiguous, right? No. Wait. Yeah, it's not picking that up. That's the format result. Okay, I think I need an anonymous lifetime here. So let's yeah, okay, now this works. What do we want? We want right. F. Want to write the token type followed by a bracket, then the text of the token, then a space. So it basically gives us something that looks similar to the original source code, but with like quote-unquote annotations about what the actual tokens are. And we use self dot type and self dot text, and this can be the debug format of the type. I think that's all, and now we can just tokens. Token doesn't, oh, because it's a result. Okay, so match tokens, probably we have okay. The silly actual tokens, no. I want maybe up here, and then we can do that. Error. Why panic? Error while lexing, then print the reason. Lexing file, let's put in the file name as well. File name. Lexer token doesn't implement stat format display. Well, it does, I believe. Wait, doesn't. That is strange. Why doesn't it find that? Like, wait, we do have, yeah, we do have a vec here. So is vec like too dumb? Too dumb to detect that? Because I think it's smart enough. Like if its contents can be formatted, then it should be able to be displayed, then it should be able to be displayed itself. Display. Let's look at impl. Impl clone ta clone blah blah. Okay, I guess it doesn't have an implementation. Anyways, what we can do in that case is tokens.enter think. Oh, wait, there's like a string join function somewhere. Dot join, I always forget. Is that a function? To own. Is that a thing? No. It's not, probably. They're split though. Trim. Maybe we just want. I just want tokens iter map the token to a format all of them into the same formatter. We need a formatter object for that. Maybe string from t. Is that possible? Not entirely. Well, it is possible, but then I have to collect it somehow. No, that's not possible. Because maybe I want it for each. How the frick did I do this? There must be a simple way of doing this. Oh, fuck it. That's in slice. No, that's in... Okay. Join 0. Yeah, okay, yeah. Okay, we can do this. So it's basically the inverse syntax. Some languages have it the other way around. So is there not like a t iter map t dot print? I don't know. I could use... I guess I could do this, but I think that's rather wasteful, but I don't care right now. Let's join with a space. And let's also remove that space from here. That should be... this, I believe. Can't build string from the iterator because... Let's try vec string. Okay, that works. Why is this... Gosh darn it. Okay. Well, that was an adventure just to get this damn thing to pretty print. Okay, comment. This is a comment. Function identifier, open parenthesis, close parenthesis, open brace, const identifier, colon at 64 equals plus 78, blah blah. Great. I think we have it. Let's remove all of the debugging code because very clearly don't need that right now. I guess I want to keep those, but only for logging. So as a final thing, let's maybe convert stuff to logging. And is there like the log crate? Is it log? And then we need simple logger, I think. Let's just try star on both of those. I think that's it. Let's see what the builder says. It says that it's fine. So let's use log 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 debug, I think it is. Yeah, that exists. That's a that's for if you don't know, this is like the standard logging crate that we use, and it doesn't actually define what you do with the logged messages, and simple logger is just a very simple crate that takes all of the messages that you put into the logging system and prints them out to the console, like with the time information and the like level and also the crate name or module. And it also has some simple options for filtering output and stuff. So if you don't need like complex logging to files or anything, and like me, you're just using logging to selectively enable and disable messages, then that's really great. Also, right now, if I just do this and run it, apart from it needing to compile thing, it will not print out anything because I haven't configured a logger. So as a last step, let's do that. I think it should be as simple as simple logger init, and there's just a wait, no, let's actually not do that. Simple logger init env init with level. I think we want init with level. Yeah, there's yeah, level debug maybe. This should be log level. Yeah. So you're seeing like this is simple logger, which is what actually handles the logging. This is what the handlers do in the Java logging API, which is, in my opinion, the greatest API ever written. Apart maybe from the Java datetime API, which is also really great. Like, say what you want about Java, but the libraries are partially really well written. Anyways, so this is the handler basically, and this is the backend. So unused result, let's expect that, expect couldn't. Okay, and now we should, yeah, okay, cool. Now we see these debug messages, and if we don't want them, I can set the level back up to like warn or something. Boom, and then they're gone. That's sick. Okay. Thank you guys so much for watching. Before I go, I'm going to just commit all of this, I think. And now, like, instantly the cargo log gets increasingly full because log has quite some dependencies. Like, most of them are smaller ones, like I2A and lazy static are really small. I think config if also. But time, for example, is giant. It's a giant fucking library. And it's used for this printing here. Anyways. Bootstrap. Parse the simple file. Lex the simple file. Other changes include. I'm not going to bother like to atomicize this because it's not important at the moment, like at this early stage. The changes include proper logging and reporting. And also before I commit like it cargo toml with 2 dependencies, which is a bad idea, I'm going to look at the package information to see what the version is. 0.4 and 2.1 for simple logger. 0.4, 2.1, and let's do that because that will auto upgrade all the dependencies if necessary. Like if 0.5 comes out or 0.4.3 comes out, we just get the update for free. Cool. Let's stage everything and commit that. Let's actually make sure that these files are formatted. They're not. Okay. They're both not formatted. Git commit amend, no edit. Cool, and wait, no, I have to add them first. Cool. That's 50 minutes for you again, like 20 minutes of that is me fucking around with crates. But I hope you liked it nonetheless, and until next time, goodbye.